Hi everyone, welcome back to making a Pokemon save editor in C. I think this is part 12 if I had to guess. So in previous episodes we started to, having already made some very basic modifications to the save data, we started to look at how can we modify a Pokemon's internal data, and this is probably the more challenging part of making the save editor because it is intentionally kind of obfuscated. It's intentionally made difficult to edit. However, we are leaning on some excellent quality write-ups on Bulbapedia, and it kind of breaks down how you can essentially reverse the encryption of this data and modify it. So part of that involves basically what's called a personality value that is attached to your Pokemon. And based on that personality value determines the order of some of this internal kind of more sensitive data that the devs really obviously didn't want you modifying. So if my personality value of like a certain Pokemon mod 24, whatever it resolves to determines the order of the data for that Pokemon. So my Squirtle actually has EAMG because its personality value mod 24 was 15. So what we were looking at last time was a way in which we could successfully load this data and make it kind of accessible in a predetermined structure. So I've got a type here called Pokemon data type, which is a struct which has the different sections kind of not encapsulated but defined. So the challenge is in reading in or kind of initializing this struct dynamically. So I was looking at doing this in the last episode, but I'm pretty sure I definitely have made various mistakes here because I was running into seg faults. So my idea last time was to just use malloc, and return this data type object because I was declaring it here in my main and then trying to use like memcopy on it, which I don't think is correct. That memory needs to be somewhere. So yeah, I was looking at that, and I was also looking at trying to print the actual data, which I've probably made a mistake there as well. So I was a little bit stuck at the end of the last episode, so I actually consulted the AI, and this is some Svelte stuff, work related. So in C, I said, let's say I declare a variable pointer on the stack. Can I then call an init function which takes that pointer as the argument and then assigns a value to it via something like memset or memcopy before returning it? Will this variable be initialized back in my original stack? And the AI says yes, and then you can use memset or memcopy to your heart's content, blah, blah, blah. But obviously what I'm not doing is actually calling malloc, which I believe is what I was missing. So, interestingly here, it's so the clue is that I need a pointer to a pointer, and then I can initialize inside of this function and do whatever I need to. And it's actually a void. It doesn't return anything here except maybe null if it errors out. So I was kind of looking at this code and I was like, well, this is probably the answer, the solution to my problem. But my follow-up question was, is there actually any benefit to this code over just using malloc in the main function? And I tried to say, I'm not trying to trick you here. That's not intended to be a leading question. And it says, you know, there's some benefits to it. It can help with readability, and if you're wanting to encapsulate stuff, you can. So does it do I really need to do the malloc in here? Probably not. So, well, actually I say that. Actually, saying that, I think I do, because I probably want to keep this kind of portable. So and I mean, it does take it does use something from outside of itself and modify it. So I guess it would be interesting to see how other init functions work in C, whether it's a similar principle. So whether they do actual memory allocation inside, or if you do that outside. Because the thing is, I mean, I don't think it matters if you were to call malloc here, but you would have to free this. Maybe that's another question for the AI, actually. I mean, did they... Okay, yeah, it's free because you need to free it because it's dynamically allocated. So maybe it's not a great idea to do that. To do that there, at least. Maybe, I think, maybe the function itself just needs to be get the actual substructure order and then assign the data that way. So if I'm doing that, I don't need this pointer to a pointer with malloc. I'm going to do malloc in main. So let's do that. So where am I calling the init function? Here. So what I want to do is have a Pokemon data type pointer cast from malloc size of Pokemon data type. So then I can pass in PDT there, and it should be fine. And then my other thing is that I actually need to, if I'm loading the Pokemon data in this way, I need to what do I need to do? I can't even remember what I just said. Yeah, so this function is to initialize the inner data of a Pokemon. So I need a type or a variable to which I want to load that data in, and then the Pokemon that I'm focusing on. So I believe this is fine. I believe. Yeah. And so this may actually work now, but I don't need to return D. Then let's do like return null just in case anything goes wrong. And then I believe it's complaining about this because it conflicts with my header, which it does. And then not all control paths return a value. But I don't, it's a void. So why does it care if I'm returning? Or can I not return anything at all in a void? No return statement in a function returning non-void. It's not non-void. I do wonder, okay, that I seem quite sure there nothing is necessarily wrong, so I don't know if it's just the LSP messing up. No, it is not. But it's not a non-void. That's what I don't get. Does it need to be rebuilt? Non-void function does not return a value here. So why is it? Yeah, functions in C are not required to return something. And I'm not assigning to that. So what? I don't get why. Oh, hang on. It's not a void pointer. God. There we go. Okay. That was silly. Although I think we do... let's actually check if we do still have the option to return null, or is it going to complain that we're returning in a void function? Yes. Okay. Should init functions... I'm just going to say R values. In C, not Python this time. Okay, so this says fluency. A samurai returns victorious or does not return at all. Write a wrapper for all the library functions you use. Call the real function. Oh, 0 means no error. Boolean plus error number. Okay, I mean, there's lots of different things we can do there. I mean, I think we can keep this as a void because there's no reason why this switch should ever... You know, if we're doing an operation that's mod 24, we're only ever going to get between 0 and 24 or 23 as the answer. So I don't think we need to be doing error handling and things like that, because I'm like, how could there ever be an error? Okay. And then maybe 4. I'm pretty sure this is how you write to... Yeah, std error. In fact, I'm not even gonna entertain that idea. Let's actually focus on trying to solve the problem at hand, which is I was doing this wrong. So we have some memory allocated, and then we have init inner data, which actually assigns some stuff there. then we need to do all of the other cases, but here, so this is actually a pointer. So, or is that actually the resolved value? I think that is the resolved value. And maybe I do need the ampersand. I don't know why I was thinking either one was fine. So, in that case, let's try running this code again. Where am I here? About terminal 1. Okay, this is useful. So, my Pokemon FR is wrong. In fact, actually, I'm going to copy... I've made so many backups, I don't want to lose my original save. So Pokemon fr.sav. Yeah, so this is our original save file. And our main function, I believe changes a nickname of a Pokemon. So it asks us for a nickname. Then it opens our save file, loads the save data, then gets the section we want, the team and item section. Then it grabs the first Pokemon from there and sets its nickname to the new one that we've written by doing cool stuff like encoding the text and things like that. Where does that actually happen? That's the original bytes. Oh, maybe I'm not changing its nickname and I'm just like saying, hey, this is the original nickname. Unless I'm blind. Because surely we would have to call text encode. Oh, it happens there. Okay, we encode the text straight away. But then what we do, once we've set the nickname, is we want to try and load the order of internal data in the Pokemon. So it says, you know, this is your Pokemon's personality value mod 24, so we know where to look. And then we try to initialize that in a data structure. Now, we should have the path EAMG. So actually here in my default, just for the time being, I think I can just do memset like I had before, which is memset. So B is the string to which we want to write that. So and size of Pokemon data type. Yeah, so we know that something's gone wrong if literally everything is FF. Or let's do something else, like A, E. I don't know. Something that will look weird and isn't also used as like a padding value in the save file. Anyway. So it's going to ask us for a nickname. I'm going to say Nick. And then our Pokemon's growth data allegedly is 8F over and over and over again. Now that's certainly interesting, but what I might do here for the very first time is actually use the debugger. Okay, interesting. Let me see here. Okay, alright, fine. Okay, so yeah, this gives us a familiar looking kind of set of things, and this is going to be tremendously difficult for you guys to see, so let's do 150. That should be good enough. Let me just cancel that for the time being. So we somewhere have PDT, so this is our Pokemon data type pointer, and inside here we actually have a whole bunch of values. Can it show us? Can we inspect that as hexadecimal? But this actually, I mean, the numbers are different. EX experience being 0 doesn't look right. So this could actually be incorrect. But it's also encoded, isn't it? So, I mean, actually, this doesn't look right either. Because, like, how is ribbons and obedience? But then it is intentionally obfuscated data. The issue is I don't really know if it's right. I mean, we could actually check and see, do we hit, like, this path, the path we expect, which should be this one. I mean, it must do, because otherwise all of the data would be AE. So, yeah, okay, we do hit this path. I mean, we should probably check that it's not BSing. So, like, my Squirtle's personality value allegedly should be 8DE14. I don't even know where I'm looking. 8DE. Oh, this is its nickname. So where is it relative to the nickname? Pokemon data. This is the same article twice. I need to look for... So there's data substructures, but what I'm looking for is a Pokemon data structure. So it comes before nickname, 8 bytes before the nickname. Oh yeah, 5F, 4F, E1, 8D. Nice, okay. However, is my computer also not Little Endian? Okay. So that data does actually look right. So it's read the personality value correctly. In fact, I say that is... Okay, yeah, 4 bytes long. So that's fine. Okay, maybe it has loaded our data properly then. Also, this is interesting. Memory view. Okay. Fine. Let's say it's correct. And now we have to implement all of the different cases, which is going to be fun. Although maybe we don't need to do that straight away because I've done a lot of just formatting on here. So EAMG, our data has loaded. Do we still have output actually from the run? So I don't know if this is right though, because it's just saying that my Pokemon's growth data is just 8F. All 8Fs. But that could be an issue with how I'm like kind of printing that data. So let's actually go back to where we were. So this is our Squirtle, and there's its personality value, and then this is its nickname. So the data relative to the nickname is 20 after... And then what is our team items section? So there's Oh my gosh. Itchy eyes. Although I think I can probably just like, I can just go to a specific address. So from the nickname, or actually, oh no, personality value is first. So my Squirtle's data starts here. Because that's the, yeah, sorry. So that's the 4 bytes from the personality value, then the OT ID. Okay, so from here, we want to go forward 20 in hex bytes. So 12038 plus 20. 12, okay, yeah, 12058. So it should be this. So why it's saying 8F, it's at least doing the first byte. So maybe there's an issue with that. Maybe we need to do that and increment the pointer. No. But let's actually see if the growth data is just pure 8F, 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 8F. So in PTR, oh wait, no, that's our, oh, hang on, pointer is the nickname bytes. Sorry, what I need to be doing is this. Yeah, my code is totally messy. Wow. So what I'm actually looking at is PDT, which is not here. Oh, null? Has this not been initialized? Oh, is it? Am I at this breakpoint or am I at that one? Okay. I'm just stupid. Right, so growth. Oh yeah, it was all of these numbers. 8F7 or 8F83 74 0A. Well, I see something like that here, but there's a CF missing. Although actually, if I go back to that, this should be E. So this should actually be PDTE. 8F8374 0A. Yeah, it's there. 000. Then we have 06. 0FF1600. How is Pokemon data type laid out again? So E is actually at the end. So EVs and condition is set at the end. Yeah. Okay. And these aren't really values that we're going to necessarily know about. So really what I should be looking at is growth. So if we go to the species value, 8F83 is, well, the encoded value of the species. I think what we need to do is actually try decrypting this data first before we can really deal with it. I'm just trying to check if it lines up with what we expect to see in the file. And I mean, I see similarities, so I want to say yes. I mean, I don't think there's issues with this implementation. So let's go with it. Let's go with it for now. So if we have a so if we have that data type there, let's look at how we actually do the decryption then of that data. So I did say it somewhere. I think it might actually... Is it in this article? Yeah, so they're stored in an encrypted form. We want to decrypt the data, then validate it. To validate the check... Okay, somewhere else in the Pokemon data there's a checksum. But first let's look at decrypting it. So... to obtain the 32-bit decryption key, the entire OTID number must be XORed with the personality value of the entry. Yeah, okay, so... So this key is 32-bit. Oh, actually, yeah. Sorry. Don't need to say const there. So for the inner data decryption key, we just need the actual Pokemon. And it is so an XOR. So it's the carrot. Yeah. So this is the... What was it again? The original trainer ID number and the Pokemon personality value. I kind of do want to rename... kind of do want to rename it that. Yeah, okay. Let's just call this decryption key, and that is... I need to actually put this in my header file, don't I? So then here, this is pkmn get inner data decryption key and our first Pokemon. Yeah. In fact, let's just say just add a little bit of I knew that was too good to be true. The Vim replace, we'll just use the ID one instead. So yeah, that's our decryption key. So then we overlay it 32 bits or 4 bytes at a time. But does it need to go in that order? I think it might. 32 bits or 4 bytes at a time. Well, actually no, because these are 12 bytes each, so yeah, we can do them independently of each other. So yeah, let's do that. So I guess we need a new function now to decrypt the data. And should we... I'm not going to modify it in place for the moment. However, I will eventually, I think, because for the moment, I think it helps to keep them in separate variables. So this is actually going to be source, and then we need another Pokemon data type pointer for dest, and then we need a decryption key. So for this, yeah, XOR 32, or let's say 4 bytes at a time. So if we're doing 4 bytes at a time, so we have a word, then for the size of a Pokemon data type, we want to do I+4. And we've done this before. We've literally done this before. I think it's in our main function where we were doing something like that. Yeah. Actually, let me put main not there, up top or on the bottom, whatever. So what we were doing there was mem copying every time. Oh wow, I could reassign word every time, but sure. So what we need to do is actually load our word. and then that comes from the actual Pokemon data type, or from source. I think this needs to be a separate not word, but source. It's not even a cursor, really, is it? But whatever. But then if we're doing pointer arithmetic there, and actually is memcopy just the raw number of bytes? I think it is. Yeah, n bytes from memory area. Yeah. So, okay, that's fine, but I think we just need to increment I once. Oh, but then size of Pokemon data type when we're doing... That's the thing. Is it size of Pokemon data type? I think it. I think it still can. No, because I. Do I need to divide this by 4? That's what I don't know. Because this should be incremented by 1. Because we want to increment this pointer once. So I won't be size of Pokemon data type before it's exhausted all of the data that's in there. But then do I... this might be a question for the AI. So I want to read 32 bits at a time. Yeah, I want to read 32 bits at a time in a for loop from a custom struct of various what would the for loop condition look like here? Oh, divided by the size of a uint32. Does this work on... Because, I mean, if we do a division, does that not turn this into a floating point number? I mean, maybe. Maybe not. I mean, we can give it a try. So this copies the word, or well, the data that we're currently at into there. And then we need to yeah, do the XOR. So that is defined here. So not there. Oh no, is it there? By XORing it, oh yeah. So actually, oh yeah, sorry. XOR doesn't matter which side we put them on. So and then let's have like decrypted words. So let's say decrypted word is that I don't know why it's doing that. Our decrypted word is simply word XOR'd by the key. What's the matter? You gonna tell me? Hello? Oh, no, I don't want to do that. Oh, I guess. So yeah, that's our decrypted word. And then we want to write that to our dest. But then that needs to be a pointer as well of I'm just gonna call this like source position. And we'll do that. I mean, this actually can just be yeah, size of UN32T rather than 4. So this is where we're copying to DST pos. And actually, sorry, our I needs to go up by 1. And we want to copy in the decrypted word 4 bytes. And then we need to increment that. I hope. But I think that should be fine. So then down here, now that we have the decryption key, I'm also gonna comment that out. Now that we have the decryption key, yeah, let's do another malloc. And then what is it called? Decrypt inner data. On that, this Yeah. And I need to fix the typo there. Wonderful. So I would be very interested to see what our decrypted data looks like there if we don't have any mistakes. So we didn't crash. But this is not right because that's just all zeros. So yeah, that's definitely wrong. There's definitely a decryption key though. Oh, hang on, this doesn't do prints, does it? Fuck. Can I do it in a console? No. Sorry, that's not going to work, is it? Yeah, okay. I mean, we could just copy its value, paste it in here as base 10, and then look at it there. So apparently we do have a decryption key. And it's supposedly did all of my things. So let me actually see what I was doing with. Oh, actually, data here is a. Oh, hang on, but this is an integer. Data is an array. So unless we consider the source Pokemon data type to be that, but then I don't think that's going to work, you know. So I expect in this next loop for these guys to go up by 4. Yeah. Yeah. Okay, so it is incrementing the pointers properly. So we have a word here which is just 15. Then 0, then 0, then 40. Okay, so there are values flowing through. What is this again? 69278293 4211 855. So does that data actually exist here anywhere? I mean, I'm not sure if it does. Or are we actually even looking at the data section right now? That should be it. Because Word is our data that we're loading from, yeah, the actual source data. 42118. Oh, well, either way, I don't see it, so I'm not 100% sure if that's working. But this doesn't. So the pointer's going up properly. in each iteration of the loop. Oh, that should not be plus I. That should definitely not be plus I. I don't think source pos can be made const. Surely not, because we're incrementing it. What? That doesn't make any sense. Although actually, hang on, I did source pos plus... Oh wait, no, that was in my mem copy. So... yeah. Yeah, whatever. So... Oh, sorry, I should have zoomed back in on the IDE. Change with... I need to look at my actual Mac keyboard for this. Control, Option, and equals? Oh, yeah. Okay. So I need things like decrypted, but I need species not to be 0. That's kind of my issue. Yeah. That is kind of my issue here. So why does that not... work? Decrypted, our source is PDT. Because what does surprise me is that destination is just completely empty. Oh, wait, hang on. Decrypted word and memcopy is definitely dest first. It is. So that should be UN32 again. Yeah. Okay. Okay. I mean, that clearly wasn't the problem. Right to that pointer. No, we did allocate decrypted. And it is Pokemon data type, okay. Oh, hang on. Is it necessarily doing it in the right order as well? Because I think we need to be loading this in the same order in which... Oh, no. That should be fine, because we're literally just taking whatever data we have and slapping it back onto itself. So that shouldn't matter, I don't think. I just don't get why... the destination is completely empty. That is bizarre. What would be interesting is to see kind of see where we are in the actual save file. But then the problem is Pokemon data type isn't in the save file, so we can't look at kind of where specifically we're reading the data from. Clearly, this is where the difficulty lies. Let me just run it one more time and actually try and trace through what's going on. So we have these pointers which are reading words of data. And yeah, it did it 12 times before finishing. But then when we actually look at our decrypted Pokemon's data, it is fuck all. So what am I doing wrong? So we're doing mem copy at the address of decrypted word. I kind of want to go back to that loop actually. Decrypted word. Yeah. 0 of 4 bytes read. Oh, but source pos works. But then why? Why does source pos work? Mem copy to our destination. Oh, wait. That might be why. That is reading data now. Okay, alright. That might have been my issue. Oh. Ah. That is probably saying it was about to give me a seg fault. What if we run it normally? Yeah, okay. Well, that's new. At the very least. It started writing it, then failed, so it's probably something to do with that. I mean, we're not writing that many. We can't be we can't be. We're either reading from somewhere we're not supposed to or writing somewhere we're not supposed to. Does it actually tell us where the, like, what the last line executed is before we crash? Oh, it was about to actually finish. So it did actually get to 11 or 12 iterations of the loop. I wonder actually if we can do... if we can do this a little bit differently. Let's use calloc for count objects that are size bytes of memory each and return a pointer to the allocated memory. Yeah. So we want one size of Pokemon data type in our decrypted. Yeah. Yeah. And the reason I did that was so that we can maybe do... although actually no, we can just read desc directly. What am I doing? So if I did things like this... oh. It should be loading stuff into dest. When we try and... do that. Yeah. That doesn't seem right. Because hang on a minute, this is saying... that we have a... yeah. Why is it saying that source... oh, is it that it needs to... no. No, it can't be that. Huh. I am stumped. What confuses me actually is that source is somewhere completely different to what the pointer is saying. Because surely... oh. Okay. Like, what? How come it's not saying 0xA74CF? What have you? But fine. Okay. Oh, hang on. Destination position is the same as the key. Now that can't be right, surely. Oh, but then word is 0. Okay, so I guess that makes sense. So decrypted word should be 0 in our case. Oh wait, no, actually, sorry, no, it is the same. It is the exact same value as the key. But then that's strange. Decryption. So shouldn't be anything to do with that. But it just completely fails to read. Oh, well, it fails to read from source as well. I don't know what's going on there. Because they're definitely initialized. Because, like here, before we go into that function, we have PDT which is initialized with stuff, and that is our pointer, yeah. And then we have on the next line we have decrypted, which is initialized with zeros everywhere. Yeah? Yeah. Oh, I didn't know UN8s had terminators. So that should be fine. Because it's also, yeah. So then in here we have a word. We have a source position from which we're reading, and that's set to the same memory address as source. But we're saying point to 32-bit words, and same with destination. So then here we're saying get word, copy the size of a UN32T, which, I mean, surely is just going to be just 4, yeah. Reading from the source position, do that. And then we get a value decrypted word, which is simply our word that we've loaded XOR'd with the key. And then we copy that back to the destination position. And then we increment both by 1 in the for the next loop. I don't know. I don't know. I might have to call in the AI. We'll just do some vibe coding here. This function appears to return a segfault. Can you see why this is happening? It lies with how I'm treating the source and dest pointers in the loop. I am taking the address of the pointers. Oh, for fuck's sake. Really? Really? That would explain why... Okay, yeah. That would explain many things. Let me not get ahead of myself. Let me actually read everything else that's saying. Inside the loop, you are... where the addresses of your source and dest pointers are on the stack. Well, that is related to 1, right? Since incrementing them moves them forward by 4 bytes in memory, that is what I want. I'm stepping through the memory locations where the addresses of your source... Yeah. Yep, so that's that. Okay, sure. I'm sure you have your recommendations, but that's how I wrote the code. So it didn't error out, so that's a lot better. But let's just go straight to this printf for now. So now in decrypted, there is some data in here. However, that species number looks pretty wrong, as does the XP. Friendship 48 could make sense, but yeah, okay. In base 10, sorry, I did that wrong. 1, 9, 4, 5, 6. In base 16, 4C00. Yeah, surely is index number the exact same? So species is an index number to identify them in the game's ROM. Huh. Well, I guess we can do the verification to see if we've actually got something like kind of wrong. So let's see if okay. The issue is that we have a Squirtle, which is 7, so it's not exactly going to be like here, which is Golem, is it? So I'm pretty sure that's not right, but there was a way we can verify this. I think it was something to do with somewhere. I have so many tabs. This guy... To validate the checksum, the entirety of the 4 unencrypted data substructures must be summed into a 16-bit value in the encapsulating Pokemon structure, which is here. So there is a checksum in the Pokemon at 01C. So Squirtle's checksum is 5134. Or 140E. And this is saying that the entirety of the 4 unencrypted... If we read that... Yeah, add all of the unencrypted values of that section 1 word at a time If the computed sum and the stored checksum do not match, the Pokemon is interpreted as a bad egg. Okay. Okay. So we need to do basically the same thing again. Oh, hang on. There's no way this is correct because we only have one move. And I'm pretty sure the PP of that move is not 137. So there's no way this is correct. Like, that doesn't really make sense. There was also something like where we found the Pokemon. The Met location is apparently 7-6 and then has an L next to it. Sorry, 76 is 4C. And that is not Pallet Town. That would be 5-8. So we have definitely got this wrong. I would be interested to see our source data, which is PDT. Oh, wait. Why does that repeat twice? Growth and attacks. And surely this would be... Oh no, maybe not if it's 32-bit words, but I'm still not convinced by that. Would that be... No. What's interesting is that this seems to repeat. So now I'm questioning whether this is even loading correctly. Actually, think I may have a mistake here. And I'm pretty sure it's because we're repeating the read like every single time, which makes sense why these start with the same thing. So, oh yeah, we've been absolutely going crazy with our memory. Yeah, what is happening is I need to probably not do that in a for loop and just do it like this. So that would be data 0. Whoops. Then that should be from position 12. Or actually, should that be if it's 0 indexed? I don't know. But either way, yeah, I don't think we need a for loop. And this needs to be a E. So PDT now should look different in its different sections, which it does. However, the species, well, let's look at the decrypted data. That would be a bit more. I think that's still the same as it was. Oh yeah, because I suppose it would always read the first section properly. That was our 4C, yeah. 4C00. Huh. Oh wait, hang on, that's oh no, I'm looking at decrypted. You zoom in. So decrypted there is that yeah, there's still a bunch of garbage there. But at least we can be a little bit more sure now that we are, like, maybe these make sense. That's a bit, These are all a bit sus. We shouldn't expect to see anything in move 3 and move 4. And the PP obviously should be an ordinary number. So we also need to have this kind of guarantee that we're reading the data in here properly, which I guess we can't be sure of. Damn. Okay. I think we at least have made some progress. I'm just annoyed that I keep making so many kind of silly mistakes and typos, but it's all a learning experience. I just wonder where the mistake is, that's all. We've definitely mapped out our Pokemon properly, or at the very least up until nickname. So I do believe it's loading the genuine data block of the Pokemon. So yeah, I'm not sure where we are going wrong, but that is part of the fun, I suppose. Does it maybe help if we see this in memory view? In fact, let's see PDT now in memory view. So maybe this can be a bit more aligned with what we actually expect to see. So 8F83740A, then a bunch of zeros. What about actually just growth? Is just this section, and that was EAMG last. 0F1600. Yeah, okay. I do think it's maybe loaded, it has loaded the data properly, because that is in the growth section. And we know that Squirtle is supposed to have growth last. So that seems okay. But it's just like, why is species that number and in the decrypted as well? Like, that doesn't seem right. Hang on, does growth start from in memory view? Oh, it starts from here. Oh, okay. We need to do this contiguously then. So I think where I've been messing up is I'm not supposed to, because the thing is I'm decrypting 32 bits at a time, which would be from here to here. But then if I've got my nice custom data structure that I was using, I'm decrypting from here across here, and that's not right. I need to be doing, if we assume, just for argument's sake, that Pokemon data starts here, I need to decrypt that. Then I need to decrypt that. Then I do and so on. I can't start from here and just decrypt that one section. Yeah, especially because they're only 12. Oh my god, especially because they're only 12 bytes each as well. I just need to do it in contiguous blocks. But then hang on, there's 48 bytes total, and I'm XORing. Oh, sorry, 48 bytes total. Yeah, okay, fine. Yeah, that makes sense. Okay, I think I know what I need to do. Am I going to stay up and actually do it? It's kind of late. I might write up some notes about what we learned and what we can do for next time, because I should probably think about going to bed soon. So let's do some notes. Do I want to use Pokemon notes? Probably. So we are still looking at decrypting the data of the Squirtle in the to-do list. But let's do a new section here. And let's just say, like, here's our findings for today. And this is, so we have managed to successfully use the enum and switch case for loading in Pokemon data. We can verify that the struct loads properly. MB, this is the predefined struct. So not the dynamic block of bytes actually set in the save file. For example, our Squirtle has EAMG, but the predefined struct is set as game. We cannot... Oh wait, That still... No, hang on. That logic... Now that I'm saying that out loud, that logic still... maybe doesn't make sense. Because we intentionally weren't decrypting each block on its own. We were using 32-bit words, and it shouldn't matter the order in which we do them. So I'm still not convinced that was actually our problem with decrypting. I think what we want to do is validate that checksum value. Let's just try that one last time now that we know we fixed the loading of the save data. So our checksum should look like 2440. But what we need to do is sum all of the... the computed sum and the stored checksum don't match. It is computed by adding all of the unencrypted values of that section one word at a time. One word at a time. The unencrypted values as well. Yeah, so my mistake here is that I was thinking that we were literally grabbing 12 bytes from the block and trying to write 32-bit words based on that, but no, I think my approach was correct in using 32-bit word pointers. Like, we deliberately casted to that so that we were reading 4 bytes at a time. But yeah. What I think we should do is I'm just going to call this note from... I think we need to try and sum our decrypted struct and compare that value against the checksum for Squirtle. So that we can see the discrepancy. And let me just actually check the AI didn't spot if I'm doing something else wrong in this code. Or maybe I can just ask it again, actually. So... did that copy to my clipboard when I yanked it? No, it did not. So let me do that instead. I've modified the function so that it now looks like this. I still don't think it's performing the decryption I want properly. Are there other potential errors you can spot here? This is not intended to be a leading question. The problem is that how you are using memcopy within the loop. Whilst you are now correctly pointing, the memcopy pointer increments are not advancing properly through the structures in a way interpreted as you in 32T. Reads 4 bytes and then copies them into the... Yeah. The issue, in each iteration, you are reading the same initial 4 bytes of the source structure into word, decrypting that same word, I should treat the uint32 pointers as iterators over the... Oh, using array indexing. Maybe that's easier than doing the arithmetic with the pointers. So I don't need to actually even have that kind of separated word variable there. I can just directly... Oh wait, hang on. Is it because I declared it outside of the loop? That can't be it, right? Copies them into the word variable. The issue is I'm reading the same initial 4 bytes of the source structure into word, decrypting that same word. Is that an accurate description of my problem? I'm not sure if that's... I'm not sure if that is actually my issue. But it's late and I'm tired, so... Yeah, but it's not reading sequentially through the entire structure as a continuous block of bytes. The key difference is how I'm accessing the sequential 32. Direct array indexing, whereas memcopy combined with pointer increment in your modified version does not. Where the starting point of memcopy moving by... There's no way memcopy moves my pointer, surely. Really? Are you saying memcopy is moving my pointers? It's due to the increment after the memcopy calls within the loop. That's what I wanted though, right? I did want to increment them after. Based on the loop counter and the size of the element type. But my pointers were casted as uint32s. So to increment these pointers, I initialize them to the start of source, address of source, read 4 bytes with memcopy, copy, where my pointer does not move until I increment it before the next loop iteration. Because my pointer is a uint32, it increments by 4 bytes. What is the issue? I thought that would be correct. Okay. While each individual step you described is correct, the combination of them within the loop as a continuous block of bytes. Think of the memory as a sequence of bytes, okay. What I'm doing in the first iteration, that points to byte 0, yeah. Then we get the wormed, yeah. Gets the value formed by, yeah. As a sequence of non-overlapping 4 byte chunks. However, if the goal is to treat the... If you mean applying the XOR operation to the first 4 bytes, then the next 4 bytes and so on, your logic should work. Okay, yeah. Maybe I've just confused the AI. And I'm confusing myself. If the intention is to XOR the entire Pokemon data type structure in 4-byte chunks with the given key, my modified operation should perform that operation. Yes. Yeah, could you provide more details about the structure of Pokemon data type? I can, but I'm not going to. What I expect the decrypted data to look like. I wish I knew. Well, actually, I do know. How I'm verifying the decryption checksum. Yeah. So I'm still stuck, and the AI has said that what I'm doing was probably right. I'm not saying I refuse to use that code. I would be interested to try that. But I'm convinced that what I was doing here is just this, but with more like steps. So yeah. Anyway, I will figure this out next time, hopefully. But if you've stuck around for this long, thanks for your patience. I'll see you in the next one. Bye-bye.